Well, here's another video for you. Get my camera aimed the right way. What I wanted to do was go over some little minor war stories, including one that was complicated enough that it's hard to even explain. This was my brother's 77 Cadillac, or it's a story about it. I actually got that picture from online. But he had a dark green 77 Cadillac, and it had some aftermarket spoke wheels on it. And one of the wheels had some bent spokes, you know, and you just kind of, you notice that and it bugs you, but there's not much you can do about it. And he was a nut about getting his wheels aligned a lot and getting tires rotated and all that kind of thing. And back in those days, I don't know if any of you guys remember this, there was a time when you were not supposed to take a radial tire that had been put on the passenger side and put it on the driver's side, or vice versa. As a matter of fact, back in the 80s, I actually, you know, if somebody even sold you a used tire, if you put it on the wrong side of the car and it was rotating, it was, you know, spinning a different way than it did when it was in its regular life, it was subject to blow out. And I had some tires blow out that way. Of course, no tire that's over 6 years old ought to be used even today, even if it's been in an air-conditioned warehouse and it's never been on the ground. Yeah, a tire that's more than 6 years old is just a bad bet to use. But that's another story. He came complaining about static on his radio. When he was driving down the road, he'd have static, and he never used to have that. And so I went and I was working and trying to look at, you know, grounds and antenna connections and just all kinds of, you know, speaker connections and all that. And he was walking around the car while I had it in the shop there, and he says, you know, these guys, when they rotated my tires, they didn't go front to the back like I told them to. Now, this is a long time ago, remember, when the radial tires were older. He says they actually rotated the tires the wrong way. He said, I need to fix this. And so we jacked the car up and we put the tires back where they were supposed to, because he had noticed the bent spoke was on the right front and it had been on the left rear, and he basically wanted to keep the tires on the same side of the car. And the long story short, we put the tires back like they were supposed to be, and when we did, the static in the radio was gone. After the tires were rotated back so that they weren't rolling backwards. Now, you can't really apply that today because tires are made different now than they were back then, but that was a kind of a strange and funny story, I thought. If he hadn't happened to notice the bent spokes on that right front wheel and knew where they were before, you know, I don't know how long it would take us to figure out that there was that static on his radio problem would have been there for a while. This Lincoln that I worked on when I was at the dealership back in the early 80s belonged to some people that worked with my mother at the college over there. And they said when they would drive it for 5 minutes, when they would first start it, they would drive it for 5 minutes and it would buck and snort and cut up and jump. And so I just basically got in there and did a visual inspection. The interesting thing about Fords is, ever since they've had a crank sensor, pretty much, they've had a gray wire and a blue wire with no stripes that are going from the crank sensor to the PCM, or to where it's going. And this particular one was no exception. It was like a 82 mile or 3 mile. It seemed like it had fuel injection on it, so it must have been an 83 mile. Anyway, the point is, one of the pins in the crank sensor connector there was pushed back where it plugged into the harness up there by the throttle body. And all I did was seat that pin, push it back up in there. Now, why that made that car do something after 5 minutes of driving and it didn't do it for the rest of the day is absolutely beyond me. I mean, it was a perfect time. You could set your watch by the way the guy talked about. Just about 5 minutes, it was going to buck and jump a little bit, and it did this every morning. Never did that again after I seated that wire harness. Expansion, heat, engine compartment heat, I don't know. But it just seems odd to me that it was always the same amount of time. That's a strange kind of a thing right there. All right, this Tahoe transfer case was one that we got in there. And you can see how the transfer case chain has rubbed a hole in that housing. There's kits you can buy that's got a, you know, transfer case housing and a chain and all that, so you can basically redo the transfer case. And it doesn't really cost that much. But for the purpose of time, we went ahead and got a transfer case from a salvage yard, and it came in, you know, the salvage yard we got it from, bought it from LKQ. I don't know, but anyway, it came in dry. They had drained the oil out of it so it wouldn't make a big mess in the gas truck when he's hauling it. We took that transfer case, we put it on the Tahoe, we filled it up with oil, and I'll be doggone if that thing didn't leak. Well, this is kind of ugly. Well, you could call LKQ and say, hey, this thing's leaking. You know, what are you going to do about it? You know, but as it mounted to, we had to pull that transfer case off of there and break it down and reseal it between the halves. And that was just an absolute pain. That was work we didn't expect to have to do. You know, and in a shop situation, who pays for that? You know, somebody's got to eat the cost of having to break a transfer case down and reseal it so it doesn't leak after you got it feeling like, well, it must have been okay. I mean, the thing worked good, so it hadn't run out of oil while it was on whatever other vehicle it was being driven on. That's just one of them really aggravating things that kind of blows up in your face, you know. And the salvage company, they couldn't care less if you have to do something to work on their vehicle. I mean, work on their part that they sold you. This differential thing, the pinion bearings had died in this differential and flopping around all over the place, and it had really chewed into that carrier. And what I basically did there is just bought a whole replacement differential that we had. I had one of my guys put on there. That was a kind of an easy job. This happened at about the same time all this other stuff was happening. This one here is a Suzuki XL7 that had an exhaust leak. They brought it in for an exhaust leak, and we found where somebody had tried apparently to cut the catalytic converter off and just gave up on it because it was too much trouble or something. I guess they had a power saw. And they do that. People steal catalytic converters even now. This friend of mine that I go to church with, he's the guy that checks your temperature when you come in the door because of this COVID thing. And he told me that he has a 1-ton Dodge truck that he had out there sitting there for a while. He wasn't driving it a whole lot. But he went over to start it one day and it was really noisy, and he got under there and somebody had got under there and cut the catalytic converter off his truck. You know, he'd sell it to the scrapyard people for all this platinum and polonium that's in it. All that junk that's in there, not polonium, but palladium, you know, hogwash. Anyway, that's real valuable metal, and they'll pay you big money for a catalytic converter, especially if they're an unscrupulous scrap person. Anyway, we went ahead and said we didn't have a wire welder, and I didn't want to try to stick weld that. And I got to send it over to the welding department and had them weld it up. But I just went ahead and fired up a torch, and I got a coat hanger, sealed it up like that. Wasn't a big deal. The engine skip that we discovered on that same vehicle, though, we found it was a GTC 505. I've actually got another video on my YouTube channel called Camry Coil Adventure or something like that. It happened on a Friday morning, and I'm going to show you, you know, and tell you about that one a little bit too. But this one right here, we use this to basically, you know, compare one to the other. That we compared that one to the one behind it. And this is how many kilovolts we got on the one that was skipping. And so we just jerked the plugs out. The plug was new, but it was greasy. We popped a new plug in it, and we fixed that thing in 10 minutes, which was a whole lot better than, of course, you know, the plugs were new anyway, but I guess I had a bad plug or something. But they weren't even complaining about the engine skip. Of course, we fixed what they came in for first. You know, that's really important too. This one here gives you the 4 screens on the Toyota Camry that we did. It basically had a really high firing right here. See that? You can actually, with this GTC 505, and you can buy these things on Amazon. There was a friend of mine that works for that company up there at General Technologies in Canada that sent me one of these whenever they were brand new and they weren't even on the market yet. And I just loved that thing. I wouldn't take anything for it. They don't cost that much, but it's like a scope in your hand, and it's you don't have to unhook anything. You just rest it over there on top of the coil. It gives these, there's 16 different ways you can analyze the ignition pattern with that thing. It's just really amazing. But in this particular case, I got that pattern there, and this was 82,000 volts. And this was what a normal one looked like, 21,000. After we put the new coil on, or I was by myself that day, but after I put that new coil on there, I got one of those intermotor coils from the parts store because they sent it over real quick. I put it on there, and the vehicle ran okay. Of course, it ran okay before, but it was throwing a code for a primary ignition fault. And the original coil wasn't reading screwy. It was just reading like 22,000 volts. But sometimes it would skip and it would throw a primary ignition fault. And so the easiest thing to do is put a coil in it. You know, you could chase wires and all that kind of hogwash if the coil didn't fix it. But when we put that coil in there, I said, you know, I got this thing just laying here. I think I'll just open it up and, test the new coil next to the other one and see what it's doing. Well, I tested that intermotor coil. That thing was popping at like, 80 or 90,000 volts or whatever. And so I called the parts store and I said, I don't like this coil you guys sent. This is ridiculous. I said, this thing is firing way higher. And so he basically called Intermotor and they came up with something. They said, well, we think we sent you a Japanese coil because they fire at higher voltage. I don't know what in the world that's all about. But what he did was, believe it or not, I said, I need something right now, that you can send me that I can put on this thing that won't fire, won't take 90,000 volts or whatever to fire, 80, 90,000. He sent me a DriveWorks, believe it or not, which I never really thought much about DriveWorks. I've seen some of their front end parts the last 2 weeks before they wear out. I'm not here to trash DriveWorks, but I'm just telling you what I've seen. Anyway, I put that DriveWorks coil on there, and it ran great. And as far as I know, that thing's still on there, and this has been 2 or 3 years ago. But that was just sort of interesting story there. But if you ever decided to get you one of these things, even for the do-it-yourself guy, it's worth it, because it'll, when you get used to reading the good coils, you'll be able to pick up the bad ones and all that. This Crown Victoria patch job, I knew the person, they didn't have no money. They wanted this thing fixed as cheap as we could fix it. And so, they see it was rusted right here, leaking coolant running out of that valley down there. So what we did was we just used a high-speed cutter to cut that pipe like that, and we put a piece of hose on there with a couple of clamps, and just we took care of that for almost no money. That was something you do for, when you're not in your ivory tower and you're telling people, look, there's no guarantee on this, and if it comes apart and burns up on you, it's not on us, And a lot of these people are just happy that you're willing to do something for them. I ran into a situation the other day, near, close by here. I saw this Dodge Charger, I guess it was, like a 06 or 08 model or whatever, sitting next to about beside the street in a sort of wasn't in a busy spot, next to some apartments over close here. And the guy said he had left the apartment and he got just out of the parking lot and he started cutting up and it losing power, and it quit on him and it wouldn't start. And so when I went by there the first time, I noticed that it was sitting there with the hood open. And I came back there again, the guy was looking around under the hood, and I could, he was dressed in really nice clothes, a clean cut looking guy. And I stopped and I said, tell me what your problem is. And I interviewed this guy, and it turned out that the day right before, the previous afternoon, the last place he went before he went to that apartment was he went to a gas station that you could see from where we were standing. It was just right there on the boulevard. You could point out there, and there it was. He says, I gassed up right over there. I parked in the parking lot. This morning I got up. About the time I got out of the parking lot, this thing started cutting up and quit on me. And I told him, I said, spin it over and let's see what it sounds like. So we spun it over, and it acted like it was trying to run, but then it hunkered down and quit. He had a good strong battery and all. And I said, okay, let's think about what you did here. You gassed up, you parked, the very next morning you came here, you started it up, it died on you, and it tries to start and run but won't stay alive and all that. I said, it sounds to me like you got water in the gas. I've seen that kind of thing before. He could probably pour some heat in there or something. He had filled it all the way up. He said, I fill this thing all the way up with fuel. And he says, maybe somebody was messing with me and put water in my gas tank. I didn't want to, cast any suspicion on it, but I said, you probably got it from the gas station. So, I wouldn't say somebody did that. Although one time I did know this guy that somebody put dishwashing soap in his gas tank when I was working at the dealership on an Eagle Medallion he was driving. That cost about $900 to get that straightened out, even back in those days. Anyway, I had sent that, gas. I says, you got to get that gas out of there and get it redone. One time there was a Dodge pickup that came in there, and the guy said he had gassed up and went about 2 blocks and it quit. And so what we did was we energized the fuel pump and we just let it pump into some 5-gallon buckets that we had there. I like to do that, just let it pump everything out of the gas tank that it'll pump out. And this gas tank wasn't full, it only had about 6 or 8 gallons in it. And we had a couple of clean 5-gallon buckets there. Well, we pumped that gas out there was no water anywhere in that gas. That gas smelled really good. I couldn't tell there was anything wrong with it, couldn't tell there was nothing. You could put your hand in it and wave it around. It didn't smell like diesel or anything. This gas you could not tell there was anything wrong with the gasoline. And so what I did was I put we got our gas tanker that we have in the shop there. We had gas in there that we use for trainer vehicles and all that. And we pumped about 3 or 4 gallons of the gas from the gas tanker in there, and that truck fired right up. That's all that we did, was replace the gas in there. Because what got me thinking in that direction was he said that he had gassed it up, he went a couple of blocks, it died, and it hadn't started since. This one here didn't even try to start. But anyway, that's just, fuel quality is a big deal whenever you're trying to find a nose start. Anyway, that's one we picked for somebody that, didn't have money and couldn't do no better. This one here was a low power GM job. And what you do is, if there's higher than scan tool resolution diagnosis, sometimes you actually you got to get some actual numbers and figures, gathering data the old-fashioned way. It is very difficult using a scan tool to tell if the exhaust is stopped up. So just remember that. This one here, what we did was we got a homemade tool that I'll show you in a minute, and we hooked it up. We took the oxygen sensor out, put it in there, put a hose on there with that plain old fuel pressure gauge, like everybody's got a vacuum fuel pressure gauge there. It reads about, just a few pounds over here, and 30 inches over here. And so it had 2 pounds of back pressure whenever you were cranked it up and it was idling, and the catalytic converter was clogged up on that. Some people have had issues with Walker catalytic converters. I don't know that I've ever seen a Walker cat give a problem. Some of the other aftermarket ones will. They'll throw a code for catalyst efficiency, PL420 or whatever, a couple of weeks after you put them on there. So on this one here, we actually took the exhaust system out. We made marks on the exhaust system with a Sharpie so you'd know how it was supposed to be, in there. And we took it over to the welding department. The welding department used a cutter they had over there to cut that old catalyst out. And then we put the new Walker cat, it was exactly the right size in there. And they just had to tack it in about 3 or 4 places, as much as they could, using our lines to line everything up. And, make it, so that the cat was in there the same way the other one. And then we took it over there and put it up in there so it made sure it would fit. And when we made sure it would bolt up and fit, we took it down and we let it go in and sew it up around there. That's about the only way you can do that. I figured that out a long, long time ago. You can't just cut the exhaust, cut something, out of the exhaust and then put a pipe back in there without having it bolted up to the vehicle so you'll know it's going to be right some kind of way. Because you'll make an exhaust system, there ain't no way you'll get it to bolt back on there. That's the special tool. This right here was a plug that came with a new catalytic converter. The new catalytic converter had this 18 millimeter plug, which is just like an 18 millimeter spark plug, and added in the oxygen sensor hole. Well, I took that and I drilled it and tapped it, and I put a brake bleeder screw in there. I just drilled it all the way through, put a brake bleeder screw in there, and that's what I screw in there and check to see if we got exhaust back pressure. It works really good. Doesn't cost anything. You can buy expensive tools to do this with, but I just built that one just real quick one day, and it works so good. Slide your hose on it, and then check your back pressure. And that is a go no go test. If you got back pressure, you'll find it that way. All right. So this was a random photo. I saw these 2 beautiful old cars at the barbecue shack a while back. I just figured I'd take a picture of them. I guess they were part of some old car club or something. We see old cars around here now. It ain't California where old cars never die, but we do see a lot of old cars down here. And I'll tell you something else. In this part of the country, we don't see a lot of rust. Every now and then, whenever somebody brings a car from New York or somewhere up that way down here that they bought at a song in a dance, you look under it, it's so rusted the frame's about to fall apart on it. But we don't have a problem with rust down here like some of those cars where they put salt on the roads and all that. This 2010, now this thing is complicated enough to where I could spend an hour talking about how it's wired up, and I'm not going to burn all your time on that because it actually gets kind of disgusting and boring when you start to think about it. The initial concern was that headlights tended to only illuminate on flash to pass. Occasionally they wouldn't work normally. But the daytime running lights wouldn't work at all. The owner of the truck couldn't care less about the DRL, not required around here. He just wanted to turn on the light switch and see where he was going at night. Now you're thinking, okay, this is a 2001 model truck. How complicated can it be? Basically you're expecting to see a switch going through a dimmer switch to the headlights. Whoopee! All right, wrong. All right, so my question is, how complicated should something be? Now this right here is a beautiful little thing. There's 3 little relays here. there's two switches, and there's a fan. This one only has one fan motor. Well, I'm sorry, it's got this fan motor, that fan motor. And I actually wired up a board, and you can see that on my channel too. I've got a fan board where we wire these up. And you would use two switches and 3 relays to wire up 2 fan motors, so that when you turned on your first switch, the fans would run in parallel. And run in series, and they would run at half speed. And then when you flip the other switch, they would kick on high. I mean, they run in parallel because of the way the relays were wired. Well, see, Buick, and Ford, some of the other American automakers, they wired them up like that. Nissan, all of their fan motors have got 4 wires going to them, and they got relays that are just wacky as all get out and everything. Well, this right here is a Hyundai. Hyundai, in order to make all of this stuff work, the cooling fan motor is driven by this module. There's a fan relay, and that module basically uses some electronics to run that fan motor a couple of different speeds. Some of the fan motors on the Fords and stuff will actually have a ballast resistor that's basically the resistor will be in there in the airflow so that it'll stay cool. And whenever they want that fan to run on slower speed, they'll slow it down. Tauruses were doing that years ago. They have a resistor that would enable the fan to run on low speed when it was energized going through that resistor. But I thought it was really smart to do away with the resistor and just run the fans in series when you wanted them to run slow, and in parallel when you wanted them to run fast. All right. So what we got here, this is the S10. This is how it starts out. You got this headlight switch right here. When it's on auto, see that? In other words, it's over on auto, not on headlight, but it's on auto. Anytime you're flipping on that, actually it's not getting anything on auto. When you turn the headlights on, the power comes through here. This goes, let's love the arrows that go from one to the other back, they've been doing this for a long time. All right, that goes over here, and it goes here. You notice that? All right, now notice the power goes in the bottom of the relay. And the ground, which is basically over here out of the picture where you can't see it, it runs up here. This is ground right here. So they're breaking a lot of rules here. They got power going to the bottom, ground coming out the top. It gets better. All right. What did I do? Push the wrong button? Sorry about that. All right. So that's your headlamp power relay. That's that A that I showed you right there. All right. Look at this ground. 102. It goes through here, and it actually feeds that little part on the daytime running lamp relay too. And so you got power coming in here. This is grounded. So that relay, click. That comes on, it fires up both of the low beam headlamps at the same time. Now the high beam headlamps, when the daytime running lamps are engaged, the high beam headlamps, the low beam headlamps are not on, but the high beam headlamps, as turned on by the body controller, is actually burning, they're running in series. So high beam headlights run in series. He only had flash to pass, and that's all he had whenever he was doing that. You can see this little table they had to put together right here. There's your daytime running lamp relay. And you can see how these wires see how they're wired together right there and all that. You gotta start checking this darn thing with the test lights. You kind of expect to see power and ground at every light, that's supposed to be illuminated. Well, on this one here, let's drive you up the wall, particularly. All right. And there's your multifunction switch with your flash to pass. And see all those right there? You got C, E, D, F, right? All right. C, D, E, F. All right. So you notice those are hooked together. E and F are hooked together. All right. There's your headlamp dimmer switch input going to the body control module. And there's your daytime running lamps right there again. And so now I will tell you this too. Even in your schematics, you got to make sure that you're looking at the right one. I went to All Data, and you got to pay attention to which vehicle it is because they stack them all in there together. This one was so confusing that the All Data people had no idea how to put it so you could figure it out. Okay, this one here, look at this headlamp grounding relay. See that right there? All right. Whenever that is at rest, that goes to L, which goes to the multifunction switch. All right, let's back up for a second. Where's L? You see an L anywhere? L goes to there's L right there. See it? coming in from the top, ground coming in from the top. Isn't that great? Now this right here is an alternate, if it was ZR2 or without ZR2 or whatever. On that particular one, you notice the daytime running lamps feeds that, but on this one, it's fed from there. So, hell, depending on where that is, you see how long you could spend fooling with this and trying to figure it out, and how it goes from page to page to page to page. And here we are trying to get the guy where he can turn on the headlights and they'll aren't burning going down the road. If that's not enough, they had these relays. Some of these relays, like the grounding relay, was buried up under the dash where you could almost not even get to it. I mean, if you're going to make something like this, why not put the relays where they're easier to get to instead of cramming them up under the dash, where when you're looking up under there, that you can see the bottom of the relay panel, but the relays are sticking up, and you're looking up in there and you're trying to figure out, how can I get my hand up in there? Do I need to pull the dash all apart to make all this happen? This was an absolute nightmare trying to figure the headlights out. All right, so there's your headlamp grounding relay I was just talking about there. This is basically, I tried my best to put all this together. You might even notice the headlight switch is not even on the schematic. But you put all those schematics together and you draw lines to where everything goes. And also, it's confusing on several levels. There's 2 daytime running lamp relays shown. One of them parenthetically mentions an RPO code, but the other one just says domestic. The headlight grounds exit the first page going down and enter the next page going up. The ground that passes through the headlight grounding relay begins on the bottom, goes north through the relay, and then enters the page in the middle, headed south through the multifunction switch. Now that's just really rosy, isn't it? Complicate that by shoving the grounding relay in a panel way up under the dash, and you got a recipe for frustration. Rather than trying to contain all of this on one schematic, they should have provided a different one for non-domestic vehicles. This is absolutely ridiculous. And engineers have a tendency to do stuff like that when they're scrambling around. I guarantee you, if somebody that understood wiring could come along and rake all of this off the table and start over again, they could come up with a lot better system than this. I didn't research what GM did later on, but the simple fact was there was absolutely no reason for this to be as complicated as it was. And it's complicated enough that I could go back and read the account that I wrote of it. But I don't even remember what we did to fix it. I think we actually put a ground in there and bypassed all that nonsense so that the lights weren't running in series and the grounding relay was doing nothing, and so that when he turned on the lights, he'd have bright headlights going down the road and dim when he pulled dim. It was just wacky. Engineers can be really crazy people. One of the things that I was noticing, I told this story in another PowerPoint. There was this guy that contacted me after I went to work at a college in 2001, and he says, the lady at the dealership told me how to get a hold of you, and he says, I'm an engineer working for Ford Motor Company, and I noticed that you fixed the headlights on a Ford Explorer back in 1995 that had burned up the headlight switch after an 8-hour drive at night. I said, yeah, I remember that one. It was a brand new vehicle at the time, and the headlight switch was melted because of the current that the headlights were pulling. They just drove all night long, and like I say, it was. You remember, 95 was the first time they put them rounded looking Explorers, and they did away with a flat front and all that, different wiring, different everything, and the headlight switch wasn't robust enough to carry the lights. And so he said, well, I noticed that you repaired it by adding a relay into that circuit, and nobody ever had a problem with it again. I said, yeah, I remember how I did that too. He said, well, there's a lot of these vehicles in Europe that are burning up headlight switches in the same way that one was. And he said, and I've been tasked with coming up with a field fix for it. And I would like to know if you would show me how you made that happen. And on another video I got on here somewhere, I think it's one where I'm talking about insulated copper or something. I've actually got a show in detail how I did that. But all I basically had to do was cut the wire that was coming from the headlight switch going to the multifunction switch, and I let that wire carry the relay coil. That's the only thing that the headlight switch was pulling, because I replaced the connector in the switch. Okay, and then I pulled power from the power that had been going into the headlight switch that was originally feeding the headlight. I pulled off of that power. I used a fuel pump relay, one of them old fuel pump relays like they used to have. You know, they had the pigtail, and it was the green one. And so I mounted that thing. It had a little eyelet on it. I mounted it up in there behind the headlight switch. You would not know if you pull that thing apart that it wasn't factory Ford, because it was a Ford relay, and the wiring was soldered and heat shrinked and had loom on it. I made it look really good. But the simple fact was, when you turned on the headlights, you were energizing that relay, and the relay was carrying the load of the lights. It's basically the power that was going through the relay to the multifunction switch where you could dim and bright. See, that relay was strong enough to carry a fuel pump. I knew it would carry a couple of headlights, you know. So anyway, I took care of that. But that guy actually published that as a field fix for vehicles in Europe that Ford made that were giving trouble over there. The only reason I knew about that because that's what he told me he was going to do, that information. And but my thinking on that was somebody that's getting paid to be an engineer, you know, that's obviously got education from some engineering school or whatever, seems like they'd be able to figure that out without calling a mechanic that figured out a way to make it work at the dealership, you know. Anyway, that's about all I got for you today. I could talk for another long time, but I hope you guys enjoy this. I'm going to sew this thing up and get it ready to publish Monday morning, and I'll talk to you all later.